back at it again. Day 6. Chronal coordinates. I've downloaded my input, created the file. I've read through the problem description. I am not sure how to solve this though. Oh God, help me. No, I don't want that. I don't want that. I need a differential. Where did my PowerShell go? Okay, let's see, day 6, go on. Yes. Okay, so we want to find the area with maximal size that isn't infinite. Okay. Looking at the input, the values definitely seems to be finite. Let's start by just parsing those. Buff, new buffer, input. Type worlds. Let's have some bounds on this, maybe. Top left, point. And then maybe points, point. Blah, blah, blah. And then we have the world. Snake. Four. And then we should do fields. Line. Separated by space and comma. see if fields func then. Rune, I think. Switch. Still not adding anything yet. Blah blah blah. Another one. Rune Bool. Fyrcyklar något just. Okay, so I seem to actually have some points. Top left, bottom right. That's basically taking the min of every coordinate, max of every coordinate. It's a bit verbose. I miss Vim. I should get some Vim bindings for this. Okay, so I get, that seems reasonable. Let's hide all of this in a function. Prop. Okay, then I don't have to look at this anymore. Oh, coffee. Okay, so how do we approach this? Let's get the sample data as well. New file, sample. There we go. That didn't change. Oh, couldn't have actually tested that. Yes. So let's work with that first, so we have some reference to what we got there. I'm sort of thinking can treat this as a graph problem and do a kind of breadth first search. Should I continue with this approach? So let's say we go with the graph thing, then we would have a node type. What information do we need? Let's have a label. I'm not saving the label up here, am I? I guess that's... Okay, they don't have specific labels. I can just make one up. Then just use a number. What is the size of the Dodgers there? That isn't infinite yet. They're not asking for that stuff. And we need to keep track of the distance from the label node. And then the world we're exploring is this points. Let's kind of see how this would work. And every point would basically be a start node. Okay, so for that would be like BFS world points. Or is that a point table distance? What would that mean? Search from there with this label and this distance. And then when we have done that, we need to save this information somewhere. We need to have that graph. I suppose we could just keep a running. Alright, we need to have that information. And if we're gonna do that in a Go routine, that information needs to be stored in something safe for concurrent use. I don't know if they have. Oh, they have heap. I didn't know they actually had this. Is this funcfix 2? That's good to know. List, Tumblr linked list. Okay. Ring. Okay. Okay, let's forget about the Go routine for now. but we do need to keep a record of this graph. And we basically have nodes. Let's just make a func URL. What do I want to store that? Map point to node. Should I call that something else? Rename symbol, is that a thing? Puss. Do I need to make this? Go rename, can't find package containing Advento code. Why is that? I guess that's something I can fix to next time, maybe. But now find all references. Is there a search and replace? Repeated pause. Next match. How do I do this? Enter. Pause. I shouldn't do those. But now I need to replace those. Behind that, what's wrong? Yes, yes. Let's cut. Now let's do nothing, and then the label, we need to come up with a label. I declare not used. Don't think I need that, do I? Could do that if I actually then hopefully there's enough for everybody. Damn! Label string. I need to do contains at index. What does it? Just index. Come on now. I just want the rune at the given position. Is that not a thing? Do I need to just call this a list of? You can't use that! Do I need to cast it? Or is it wrong? Okay. Okay. And then we need right, so we need to go up, down, left, right, whatever. Okay, so we'd like to keep a, what do we have? Is it a queue or a stack? Let's pretend it's... Is that even a thing here, or do I need to create my own? I suppose I can use the front back, insert, push back, move to back, remove. Oh man, go. Put all yours on. A stack would be a depth for that. So we have plus x plus 1. And we do have -1, and we're moving Manhattan places, so we have the pussas, neighbors. And then for each of those, the distance is incremented for where did that completion come from? And then I suppose we need to check if it's already explored. Okay, this is not how to do this. We should just supply that thing. So we need to store a... So here we actually need data structure. And then we would... q.push labels, whatever. Then we would supply that queue. And then that can do some internal things. But that's basically the front of the search. We can call it tier. Is that spelled correctly? Let's say it is spelled correctly. Yes, and I suppose we can do that. The node have the label. We should probably include the post here. I don't think we're gonna need that. So much work just to get a priority queue. What is the actual interface to? Okay, type interface for use not typing any type. Maybe use as a mini heap with the following variants. Sort. We need to implement the sort interface, and then we need to implement push and pop. I thought that was your job. Oh, geez. So basically, we have to implement the storage ourselves. Oh, geez. Okay, let's pretend we have that. We push that in. And this thing we push in needs to be a node, right? So let's do that instead. Node. It has a position. Else I is 0. Puss is not a type. Type a puss. Puss. Okay, it's overridden. Okay. Let's do another find and replace. Puss position. And I want to do that where place that one, yes. That one, yes. Yes. No. Yes. No. Yes. No. Yes. Oh no. Where am I? Yes. No. Yes. Did I make a mess of things? Unknown field. Because it's embedded, is it easier than just not embed it? Jeez. What did I have before? I think I need that. Label. Okay, go away. Frontier push, search, BFS. Then just so we have all of that. Whatevs. So first we need to get the biggest one. Node. I'm just pretending that that's something that exists at the moment. And then just make life easier. Node position. Okay. Postion. So maybe if I spelled it correct. The first noun. Position. Time is not an expression. All kinds of wrong. Yes, and we're exploring that one. Add all of its neighbors. Okay, could there be an issue here with overwriting other ones? Yes, I suppose there could be if they are the equal distance. If they're equal distance from the thing. We do have the frontier, but we also need to stop at some point. We need some sort of maximum distance. I suppose we can do that and see if any of the neighbors position it outside of the initial bounds of that. That does mean that it will have infinite size, right? Because that means it's outside here and there is nothing bounding it from the outside. So that checks the bounds. Top. Push. Node. They're all different types, so let's pause. No, it is not a type, because... So what do we call it? God damn. This is why you export your types so you don't have that issue. Yeah, and then we actually need to have this queue at some point. Why am I writing this in Go? It's the opposite of a fast prototyping problem-solving language. Okay, and at some point we need to stop when the frontier is empty. But what do we want back from this? We want the graph back. And what is the graph? The graph will just be... The graph will just be a collection of the nodes. And then we can run through and count each label. Or should the graph be the map? That's probably easier. Let's do that. And also make sure that we haven't already visited that. I'm not sure if that would be possible though. If we can... I suppose that's what we do down here. Oh, I don't want to do this. Let's do... Let's do that. Oh geez. I can't over. How about that? Okay, so we're using breath first. So that means that we will always find the shortest distance to the thing. And I suppose check the bounds, but also check that it's not already explored. Because if it's already explored, then it's definitely... Could it be the same distance? No, because at this point we are incrementing the distance. Let's see if we had... So this is 1, 2, and this is 1, 2. So that's equally far from B and D. And in this case, you would basically You will go there, push all its neighbors, including that, onto the frontier. And when you're there, you push that on. And then it's on twice, but with different labels. Yeah, so at this point, it doesn't wrap the comments for me or anything. Okay, graph. Too many arguments. So at this point, that should have dequeued one thing from the frontier, and then basically continue. Then check. So if there's nothing to be done, there's nothing to explore, then we return the graph is completed, and then you can use the graph to do the actual problem. Do that, you do that. We don't, yes. And if it's already in there, we change the, what's the problem? Undefined BFSX. World. Return, otherwise we put on all the neighbors that are not out of bounds, that are not already explored. We push all of those, and then we do world. And this up here is definitely needed as a stop condition. If it's empty. Okay. Would be nice to actually have the damn queue. Do I need I don't need a priority queue because I'm inserting them in order, right? So I could basically just have a slice. Yes? Right? And if I have a slice, I will be appending at the back, say, and taking from the front. So I don't need a priority queue as such, I just need a queue. Package heap provide heap opener and type the implements heap interface. I don't really need a heap. I just need the queue. A list is probably a good then, yeah. List, then I can get stuff from the front and push to the back. And does that actually pop it? Move, push back, list, push front, remove. Does this list, how do I just remove the first one? Next, previous. It's a dumpling length, so it should be easy enough to cut off the front. Is this enough to remove from the front? Let's try to actually use this. Let's call the frontier a list. Func new, is that what it's called? New. And then we have a list. We need to implement type element value interface. Okay, I don't need to implement that, I just need to stick my stuff inside of those things. So push back, insert a new element with the value at the end and returns E. I'm not really even interested in that, so push back. This is a list. It seems like it's a list, right? Is empty, start a thing, len. Front to min, that would be front. I also need to remove that. I need to say L element, and then I need to frontier dot remove L, and then I need origin to be L dot value. What's the problem? I also need to say that this is a node. Graph declare not used, graph. wow, it's actually buildable. That's the first time in a long time. Okay, so I have an infinite loop. Stack over right, I suppose. Stack overflow, yeah. Let's see if we can do... Let's see how that goes. Yeah, quite a bit. Doom. So that's probably because I'm adding stuff that shouldn't be added. Boom. Yeah, I suppose that we will keep adding stuff here even then when we have sort of full coverage. Let's see if we can also do this. Excuse me. Yeah, so the stuff at the end there is probably quite a bit bigger. So in this example, we have 0, 1, 2, 3, 4, 5, 6, 7. One, two, three, 4, 5, 6, 7. But do you remove it from the front? Do I need to... Yes, we do have a small one. If node. If it's already explored, then we stop. Put on language. If it's out of bounds, we skip it. If it's already entered there, we skip it. Otherwise, we put it in. Would be interesting if we could just print the graph. There's a problem. Undefined puss. They are all question marks. That can't be. Can it? When do I set the label? Graph. Can I get rid of that? Go away! Let's do label, let's see. Frontier, blah 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 blah, distance 4, label, blah. Post done. When do I add stuff to the graph? When do I add stuff to the graph? I never do that, do I? I do that there. No, that's if it's already in the graph. Otherwise, we add it to the graph. Jeez. Print graph. Blah, blah, blah. We need printf. It stopped? It's not quite what I had there, but you know. Let's make it more like the other one. If blah 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 blah. Let me just check a thing here. Font. See the character. Can I upcase that using a format? A downcase rather. If no, just break that on 0. Hey. But you didn't go there. Why didn't you go there? CCC. What? There's no C there, is there? Ah. AB. AB. Am I reading this upside down? What? Oh, wait a minute. Can we... C, D, E, B. Okay, that looks more like what we want. But it stops too early. B, 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 B. Well, it's doing that too much. Okay, let's do this then. Know that distance is less or equal to origin dot distance. Can we not print this big, huge? I don't need any of those. But then why you do that? Stop whining. No. That dot is happening too much. Just if the distance is equal. That's some strange stuff going on there. How do you skip over one and then go to the next? That makes no sense. This is completely wrong. That makes no sense. If okay, and it's equal, sure. What if it's smaller? So if you know that distance is smaller than origin dot distance, then we relabel it. Then we relabel origin dot. No, then it's all good. If the distance is greater, then we relabel it. Otherwise, we basically let it be. Still with it. Why you don't explore that? Oh wait. That's oh no. Is this an issue? I don't think it should be an issue, but you know. My neighbors are Manhattan distance, meaning left, right, up, down. So those are the ways you can increase the distance by 1. So this should never happen, right? Yeah, exactly, that should never happen. Why is it not like, how is that contested with what? Like what? Okay, that one is good. Equal distance. This one, 1, 2, 1, 2, that's good. This one, it's 1, 2, 3, 1, 2, 3, that's all good. But those two, that shouldn't be an issue. Who are they close to? Who they close to? They only close to that. Oh man. Things are getting out of hand. Okay, there's nothing to be done. There's nothing to be done. Print the graph. Get the smallest element, which could be the several times with the same distance. We remove it. We convert it to a node. We get the position. We print it out. So let's say it just processed the same thing but coming from a different place with the same distance. Then it would be in the graph. It would be okay. And if it is at the same distance at that point, you put it like that. Let's do that would be oh, you dumb. What? Jeez. Is that the thing? When would that happen? If it's the same distance, but if it's longer from one. Are equally far from 2 or more, okay, so they don't count as being closest to any. Yeah, so this just feels wrong. But they are the same distance. But let's just hide that for a while. Same distance from C and C? Come on. I suppose that can happen, right? I think that's probably the real issue, because you can go from A there and you can go there. So that's what we need. We need to. Okay, and no.label not equal origin.label. Hubba hubba. We need to move that inside. Okay, that's better. Same distance from B and F. Same A and E, C and F. Is that an issue? I think that should be an issue, right? Okay, let's print this again, see if we can make sense of the graph. Okay, that looks a lot better. Is the bounce check messing up somehow? Well, that's an infinite error, so it doesn't matter really. And my 10, where did I get that from? Print graph. And graph, let's do max init y and x. Should be inclusive. Okay, we don't care about that because it's infinite, but we do care that it's not corresponding quite with so E 1, 2, 3, 4, 1, 2, 3. Does that make sense? Why is that not marked the same? Ah, okay, because it might be equally far from something else. Even though that's further away, we should still mark it. Okay, I think I get that. Even though they might be closer to... So this is closer to B than both D and E, but it's equally far from both D and E. That's... oh man. That's kind of annoying. Huh. Okay, how do I deal with that? Did not think about that. Wow. I feel dumber by the minute here. Okay. If it's already in the graph with the same distance, but it could be in the graph with a smaller distance, but then we come to these two columns. Jeez. Let's see if we can just complete the... if we can complete the count here. Areas. That would be map of room to integer. We need to make that. And then for pus. No. Then just for node. Okay, so something is 17 and something is 17 again. Okay, I think I also need to mark the areas as infinite somehow, otherwise we can have an infinite area, but since I don't explore it, I don't know that it's infinite, and then it can be the biggest one, even though it's infinite. So we need to mark that somehow. Where do I store this information? The world really doesn't care about that stuff. Can we have maybe make a graph type that has the nodes like that, but also remembers the infinite areas maybe? Graph. And then we have infinites. And that would be a list of room. And then we will be working with a graph instead. And then we would have a new graph. Frontier graph, and then we change this to be graph. Print graph. graph. Is that what I'm gonna call it? Oh man. Then we need to save that information. So I need to change that time. We have infinite. Make a map of blue to blue. And then we also need to change that. What seems to be the problem? Really, what seems to be the problem? Syntax error. Oh, I deleted that somehow. And then for no, it will only iterate through the ones that are okay, so I don't care about that. Yes. Shoot a mid-second, this is, fair enough. Okay, so we have 4 infinite areas, which is what we're supposed to have. What we're left with is 1. Okay, so let's print this a bit nicer. For areas, so label size. Some new lines or something in there. Oops. A is infinite, B is infinite, C is infinite, F is infinite. That's kind of fun at the contest. So E is the biggest. Okay. Is that the only print graph? Boop. Index outer range. And where was that? 196. Go to line 196. Labels. Really? Come on. So there's too many labels. Come on now. And then we do what? How many is that? 61. Yeah, I suppose the labels will not be in the question. To 2859, 41, 66. Oh man. Oh wow, really? Okay. I didn't expect that. Oh my god, what's this now then? What is the size of the region containing all locations which have a total distance to all given coordinates of less than... What? What is the size of the region containing all locations which have a total distance to all given coordinates of less than 10,000? Okay, I think I'm gonna need to read this thing. Part 2. On the other hand, if the coordinates are safe, maybe the best you can do is try to find a region near as many coordinates as possible. Okay, so you're gonna huddle up with the coordinates. Let's get some coffee. Okay, I think I have some inkling of what to do here. I need to, do the same. Start with the coordinates and move out, but then keep track of the distance for each location I visit. I need to keep track of the distance for each of the starting nodes. But now I can also go a bit into that infinite area, I think. What is the size of the region containing all locations which have a total distance to all given coordinates of less than... Okay. So how many locations can I find where the location's distance to all of the starting coordinates is less than 10,000? I'm mostly thinking about how I can, what parts of the code I can reuse here. Oh my god. The faster people did this in 8 minutes. When am I like 5 hours? I kind of think I'm not using Go tomorrow because this is just painful. Not that it's all Go's fault or anything that I'm this slow, but it doesn't really help. It doesn't help with the speed in any way. Okay, so what information? I have my world. The world is basically my input. And then I have this BFS to solve part 1, basically. And then I have the graph that keeps tracks of that. Should I just make, because I don't care about the infinites anymore. I do have a graph now, but I don't stop. I should basically do a breath first with a distance of 10,000. This is the ugliest one so far. Okay, so if I start a breath search and then I have a distance. Yes, so. So we have for each position. Okay, I have a position. I basically want to mark up every location that is, let's say, max distance. Set that to be the example for now, 32. I can switch to the sample. Switch to the sample. Yes, and then we do something. Grow. Gonna tweak this. Grow from position with max distance. And what will this keep track of? So I need locations. I need the distance from, for every location, I need the distance to each of the starting nodes. I have a hair in my coffee. Grow from that position so long, and then I need to go through all of the positions. So I need for every location, I need a map from a label to a distance. I don't really care about the labels, do I, though? It's enough to keep track of how many. But do I care about the labels? Position. So for every position, I need to keep track of how far away it is from each label. And my world, I don't even care about the world, I just care about this one now. So I don't need to involve that. I just need to grow, and that will return me what? It will return me one of those. So let's create that one as well. Fungus, I'm gonna call it. Make map from position to a map of labels. A label is just a rune. And then from that to the distance. And then we grow from this position. So we have fungus. We need a label. We grow from that position until we reach 0. We have func grow, fungus, map position, map, brew, and we have label, brew, position. Zero return. Otherwise, we get the neighbors. Do that whole thing again. That will be position. Like we have x. Grow from that for and we grow our fungus with this label to that neighbor position with a distance that is less than before. Then we have the undefined label. Yeah, I suppose we need to just make up a label like we did before. Labels. Oh my bad, that's not where I wanted to change that. I declare not used. Okay, so now we have our fungus. And then we need to make sure that we find all the labels. And just include those. Yeah, size 0, 4. Do I care about that position? I don't think I care about the position. Okay, and now we must see that this position have a distance. Do I even need to remember? I don't think I need that distance though. I don't need to keep track of it, I just need to keep track of which rooms we have. Okay, but let's leave that for now. Then we have the distances. We basically length of the distances equals the number of positions. Then area size plus. And then we have the area size, and we have... You're in the way, man. Go away. Yeah, max this. Okay, so this is obviously not working. Obviously. Grow. If distance 0. It's less than or equal to 0. Stop. I'm doing the sample. Make that. Boom. I grow from each starting position. So at that point, my fungus should be fully grown. Then I count the area size that are covering within the max from all of those. So why is it not stopping enough? Max distance 32. Let's just break. Okay, so there's nothing of that size. 16. I just had a somewhat incomplete thought. I think I'm being kind of stupid now. Since it's the Manhattan distance, I think we have basically a square around each starting position. Then we basically need to calculate where that square, where those squares overlap. Is it a square though? You go up 1. No, it's not a square. So this is basically growing with the Manhattan distance until we reach 0. Because then we stop. And then in the end, we are checking the overlap. But we never actually Oh man, we're not even setting the fungus. I need to do that if this is less than 0. Then fungus for my position and for my label. Label is what distance? Oh, so here I need the max distance, right? But I didn't care about it, so I can just set it to distance because I don't actually care about it. And then assign energy to a nil map. Okay, so we need to make that map also. Or could we? I think I need my outline here. Print main. Fungus, max distance 32. Grow the fungus. And that is a map. Then for each position, need to check it or create it. Typical. What do we call this? This. And then we do distances. Then we do distances declare not used. Distances. Thank you. I mean, it should stop because I'm decrementing that in every iteration. I'm using 32. But yes, it is growing quite a bit for each of those. I suppose I could just do it one at a time. So I could... Yes, I don't have to search. I start with searching from one for the whole area. Then starting from the other one, I stop as soon as I went outside of the previous area. That will reduce that, and then basically we are saying fungus at that position. We have reached that many labels. So it's a bit easier than there. And then we say expected int. Then we check this position. Reached. Do that. If reached, not looking expected, then no need to explore further. Otherwise, we explore. Okay, so now we need access to the starting positions. What do we? Oh man. I didn't think this through, did I? Yeah, okay. Okay, I see. Yeah. Reach fungus. So if this position does not have the expected number of found, if this is not within the area, then we skip it. Otherwise, we check its neighbors. But then we also need to mark this because we did reach it now. So we say focus. We did reach this now. Plus is that a thing? So this position is now reached from that label, so to speak. And that means expected. Oh man. No. Focus. I think I just lead. Area size is just. Area size 883. Should be 16. Okay. So we start with that. And we don't change the expected here, I don't think. So we shouldn't change the expected there. But we do mark each position we travel to as seen, but the problem is we can travel in loops. So that won't do either. God damn. So I do need the map and the label anyway. Man. Still need that. It's basically a set. And we are expected. Okay, starting from nothing. We go to the first one. Then we expect 0 already found labels. Go from that label, from that position. We check that. We make it. It's 0. So if it doesn't have the expected number of labels, there's no point returning going outwards from that. Otherwise we mark it as we have seen that one. We update the fungus and we go out. The expected is the same, label is the same. And that's exactly the same answer as I had before. And I basically need to count. Will that make a difference? 4 bulls. God damn. 4 position. For each position we have that map. We don't care about that. We just care about this. And if if length of the labels found at a given position equals the expected number of positions, then the area size grows. We need to do that. Poop. Okay. So we imagine we basically have a grid. We explore outwards, incrementing everything by 1. This will go in loops, but that doesn't really matter, I don't think, since it's limited anyway. Fungus, grow, expected, label, neighbor, distance. If distance less than or equal to, we stop. We check the position, how many labels are reachable. If it's less than expected, can it be more than expected? No. So, okay, starting out with the first one, labels will be 0, but we should mark the first one. We expect 0. and then we add one label. So we check it the next time, and the length will be 1. Okay. So the issue here is what? We need the push. Which go from 1. Okay, so that's something, an issue with that. Why is that an issue? Does the label not change? Labels I, range, increment, I, expected label. It's only checking one of them. Oh. No, that's correct, I think. You start exploring from A. You basically mark every square of the Manhattan distance up to the max distance with A's. And then you start with C. And you mark every square outside with C's if they are already marked with A's. And so forth. That's the idea. That's the expected number of labels already, starting at 0. If we have no distance left to go, then we stop. We get the labels. If we didn't get the labels, we create the labels. We don't have the expected number of labels here. First time around, that would be 0. We don't continue that path. Otherwise, we continue, we mark it up with, say, A, and say basically, hey, this position has reached these labels. Then we check the neighbors of the current position. We grow the same number expected for that square. I guess that would actually avoid the loops. Same label, different position, less distance. World positions. Positions. Yeah, that's just that. easy to iterate. Dum dum dum. Dum 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 dum. Dum 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 boom 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 boom. Getting a bit frustrated. Arrow size 0. None of them goes. Oh, where is this going wrong? It's not there. Fungus. I expect that many for this label. So we're expecting 0 for labels. A. So we keep growing that. And then the first time around for this B, we expect 1 label. Yeah, because we expect wait, now, did I? Ah, okay. No. This is okay. I think I know what I did now. The starting position itself doesn't necessarily need to have the expected number. Okay, we need to run out the distance, because B could have labels outside of it that its reach is in the area. What I'm doing now is that checking that the actual position itself is within the area, which is not what we want. So we shouldn't be checking that here. That check is done when we are counting the area instead. Expecting the blah blah. You still need to stop because of the distance. Okay, so my so-called optimization then does nothing. Let's print how is the distance increasing? That should never be able to happen. Well, I guess it's starting out with 32. Just do that then. So this is a recursive function. It has a stopping condition, and this is decrementing it each time. But the issue is that we spawn 4 new in every branch, whatever. So we start with 4. Okay, so I guess the issue is that we are doing like 4 times going out to 32 distances. That's a big number. Maybe I can use the what do you call the Cartesian distance as a limit. We are doing loops now also. Can we avoid them somehow? Do we need to keep track of all the positions we have visited? Let's do map position. Just see. Size 53, that's incorrect, but okay. Oh, man. So this is basically just to avoid doubling back over yourself and just exploring outwards. We can just do that because it has the default value. Dum 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 bum 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 bum. Am I using the expected in there? I don't think I am. Expected. Check. Position is with the distance from most dream points. Explore outwards. Smaller distance. I am somewhat tempted to print the fungus. need to do this in a 2-pass. This coding is so good. Don't you just love this? And then we do each row. Is that the format? Is that the order? Now I do. What's the fucking issue with that? What's the issue with that? 2 variables? Okay, fair enough. And then print that fungus. Heh. Heh. Okay, I guess we don't do that double thing. We do that single thing. Okay, we don't do the space thing. Come on now. There's still a space there though. The number 2. Let's do this. I find it's kind of curious that the sixes are not continuous. I think they should be continuous, right? Because basically we should have overlapping areas. And if we change that to that, I think I've been sitting here for 3 hours now. Kind of unacceptable. Feels so stupid. I'm not quite. How can there be a hole there? How can that be reachable and that be reachable, but not that? Suppose if you had a label there. And let's say instead the max distance is 16. Let's say the max distance is 1. That should basically just... No. If the max distance is 0, I think that should still highlight the starting points. So those are the starting points. You have A, you have C, D, E, B, F. Okay, good. And if you now grow the max distance to 1, you should basically get the neighborhood of each. You should be getting stars. I think that's about right, because D and E's neighborhoods do not overlap. But if I add increment it to 2, then we should get some overlap. No change? Really? What? That is very strange. The neighborhoods of each should grow. Okay. We have the fungus, blah blah blah. Make map position, sure. For that, yes, yes. And then we grow the fungus. Let's say we start at A. I've seen nothing. I don't know what's the... I think you must have it on the same line. Can you do that? Just... Can you do that? I guess that's a bit more readable. Distance, yeah. So we start at A. We skip that. There's nothing there, so we create a new one. We set A to be within the distance. We save that for that position. We explore it to the left of it, to the right of it, on top, below. If we have seen that position, we skip it. We have not seen that position. So we now say that we have. Shouldn't that be up here? And not down there. Does that make a difference? That makes a difference. So now we have A inside there. It grew the neighborhood there and there and there. Okay. Let's step up the max distance. Let's do 32. A lot more continuous now. But still incorrect. Okay, so how am I counting the area size now? I'm basically counting the number of sixes. Just random stuff. Seven. Yeah, 7. We are not double counting because it's a map with positions. So each position can possibly only be counted once. We only count it if it has seen. And that's basically a set of the labels. And that set is the same size as the number of starting points. Let's print fungus. Let's have a cut off hint. and then just if length becomes then we need to print fungus then what happened? Less than or equal. Let's keep that at 0. That's funny way of putting it. Okay, so that looks nothing like the sample over here. It would be helpful to overlay the actual position of the starting nodes, I guess. This is just too weird. Can I print the labels? I swapped X and Y somewhere or something. X, Y. X, 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 Y, 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 Y. Push. X, Y. Part 2. That's the scene. Plum, plum, plum. X, Y. It's just printing. Grow X, Y, X, Y, X, Y, X, Y. Grow fungus. We only stop if the distance is less than 0. Otherwise, we mark it. still doing Manhattan distance, right? Is Manhattan distance what I think it is? Yes. Up, down, left, right. Is Manhattan distance what I think it is? I think so. Up, left, down, right, no diagonals. Maybe I'm just doing this stupidly. I could just directly calculate the distance to each thing directly. I guess the issue would then be the growth thing. How is that possible? Cannot be possible. Okay, so this is how many labels each position can reach within 2 steps. So if we take D, I really want that to overlay. So that would be C, and then D would be 1 down and 1, 2, 3, 4, 5 over. 1 down, 1, 2, 3, 4, 5. So that would be D. And that would indicate how many labels are reachable from 2 steps. The 2 steps would be 1, 2, 1, 2. Okay, that makes sense. I should rather think about it the other way around. So this one is 1 from that and 1, 2 from that. So that should be 2. That is 0 from that. And 1, 2, 3 from that one. Okay, that makes sense. And then you have F down in the corner. So let's take that one. That's 1, 2, 3, 4 from that one, and 1, 2, 3 from that one. That is 1, 2, 3, 1, 2, 3, 4. So up that to 4. Is that F? So this is now saying that this one reaches 4. 1, 2, 3, 4. 1, 2. 1, 2, 3, 4. Okay, this one now. 1, 2, 3. 1. 1, 2, 3, 4. So that's 1, 2, 3. 1, 2, 3. That's what? Jag dör. Jag dör. Okay, so we have 4 steps to this one. 1, 2, 3, 4, 5. That one. Okay, 1, 2, 1, 2, 3, 4. Okay. And this one is 1, 2, 3, 4. 1, 2, 1, 2, 3. What is the size of the region containing all locations So total distance to all given coordinates of less than 1,000. For example, suppose, well, less than 32. Mamma mia! Come on now. Let's limit the printing. That looks sick. That cannot be right. How the heck does that one reach all of them, but not that one? That makes no sense at all. At all. It's an interesting pattern though, but come on. I'm just gonna let's just do this. Let's do that. Let's just print the fungus. I suppose we need the fungus outside. Yes. Let's print it underneath. What the hell? This is so messed up. Okay, so these are supposedly all the positions that are within the max distance from each label. How can it be disconnected like this? Makes no sense to me. And how can it suddenly be empty? That makes no sense. This is so weird. What am I doing? My code is doing something crazy. I should have started over hours ago. Just do the simple thing instead of this. Like, what? Oh, wow. So I'm basically growing out from each label, marking every position with the, in this case, F. F, 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 F. Then I go from that, C, 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 C. Then I go, A, 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 A. Then I go, D, 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 D. B, 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 B. And then I go back to my fungus. I go back to my fungus, iterate through all positions that have some kind of label. Down here, that is. I iterate through all positions that have some kind of label. And then, if that position have all the labels, then we include it in the area size. And the area size being the number of locations reaching all labels within the maximum allowed distance. Let's do an experiment. Let's say if okay, so those are all that can reach A. Seems silly, they should be centered around A and grow outwards, right? Because I have the cutoff. Let's remove the cutoff. Remove cutoff. And then A should now grow around A. A. What happened there? A. So 1, 2. Why is that not in there? What? Why on earth is that not in there? Is it because I go 1, 2, 3, 4 instead of, or like 1, 2, 3, 4, and then I mark it as seen, but then I go 1, 2. I think that might be it. Okay, probably should be using a Q here also, right? Okay, so that's probably the reason, because we're doing the scene thing. Yeah. That makes a lot of more sense. So what do we do? Well, we create the queue there instead. And instead of scene, should we do the frontier? Oh man, I should probably just reuse the thing I had up here. I don't even remember what that was about. So do I even need that? We put equals and then we have we don't have a scene. I think we need what do we do with this scene stuff? I don't need to start one for each, do I? No interface. Fuck. Oh, come on! How do I get it to be? Oh, yeah, it's the value, right? That's strange. It's not growing in both directions anymore. No, it's not growing as it's supposed to grow. Because it's not consuming enough of them. Is that the issue? Okay, that seems more correct at least. Like what? Why are you skipping the bottom one? And this doesn't work because it's too slow. So, do I still need a scene? faster. Is it also correct? It seems to be growing in the diamond kind of shape. Sort of. Why is it doing this kind of weird cutting off? So I add the locations by the order of distance. Do I? All of the ones that are on. I start with that, then I add that. And then I go to that one and add all of those. Then I'll take the front one, add all of those. Then I'll take the front one, add all of those. Then I'll take the front one, add all of those. Right? Do I really need that inside of there? Return, there's no return in here, right? Well, I have distance. Okay. So let's do this. Or distance 0. Then don't do that there. And instead check if then 0 then. It's not growing. Ah, okay, yeah. Because now, yeah. I need to process everybody with that. Right. I push that back, then I immediately take from the front. If I take it from the front down there. I'm still not sure what I'm doing here. Now I broke it again. What the What did I just do? I done gone broke it. Let's add in the frontier scene label. Just then basically we do more. This won't work because it is expecting floats. Great job. That's not what I wanted to do either. Well, sure. Continue outer. Oh! Poop. Okay, so I'm gonna just I'm tired of that shit. I have world has top left bottom right. So for x top left x x why if escape, otherwise we keep. Okay, not quite. So here we basically check if it's too far away for any of the things, that it's too far away, and we skip it. Otherwise, this position is part of the area. So max distance 32, running the sample. So top left to bottom right. Skip false. For that, skip true, F skip. Exercise, boom. So here we check, all. If the Manhattan distance is bigger, my stupid Manhattan thing. So that's dx, that's dy. That's distance. Why is it so much bigger? I'm not counting anything twice. Okay, so this is not working as I intended. Let's call this if skip, continue, else, just for extra stupidity, it should obviously be 0. So if the actual distance between the candidate and one of the positions is greater or equal to the max distance, then this is not a candidate. If this is not a candidate, we continue to the next one. Oh, my stupid code. The Manhattan distance. The absolute dx value plus the absolute dy value. So if it's negative, subtract the negative value. That's plus, right? Else add that value. Okay, that's better. Let's pretend that that is actually working. Do that. And then do that. And max distance 32. Oh, again. It's the total distance. Really? Really? Why can't I just read that problem instead of doing what I think makes sense? Because what I think makes sense is not the actual problem. What do you have? And the file expecting. Jeez. Well, yeah, 32. It's 1, 2, 3. I guess that's gonna take a while. Oh my god, where is my brain today? Okay, let's try that. 42250. Wow, aren't you a bright one? Oh jeez. Fungus growth? Really? Oh. Yeah, I guess I'm gonna stop there. I'm gonna go cry now. See you next time. Maybe.